Okay, we are doing an example from 5.6, and we are doing substitution to solve integrals, and we have now definite integrals. And so we're going to talk about how that changes our process a little bit. It kind of adds a step. Now what you need to realize is we're in terms of x here. Our limits, 0 to 35, are as well, and we need to take that into account as we do it. So the first thing we're going to do, just like any problem we've done with substitution thus far, is we're going to pick a u. And now it's always best to pick whatever in the parentheses, under the radical, etc., as well as you usually want the largest exponent. So I'm going to choose x squared plus 1. So that means du is 2x dx. Now I need a 6x here, so I'm going to times both sides by 3 here, so it's just some basic algebra, so that I get that 3 du is 6x dx. So here, what I've done here is this part here works for this, and this part is this, so that I can simply put these through. So what I've got here now, and notice I'm going to put x equals here. These are still in terms of x. I'm going to take care of that in a minute, but I want to remember they're still in terms of x. I have du over the square root of u, and I have 3 here as well, I can't forget. Now I could move that out front, and I probably will here in the next step. So now these are in terms of x. Now what you could do is you could take the integral, put back in the x's, and then factor these in. What I think is easier is I'm going to convert these limits to u's as well. And to do that, all you're going to do is you're going to take these two values and you're going to plug them in to this, our u. So I'm going to take the square root of 35 and put it in for x. The square root of 35 squared is 35. 35 plus 1 is 36. So my first one is going to be 36. 0 squared is 0 plus 1, 1. So now what I've done here is I have 3, move that out as I said, 1 to 36 du over the square root of u. So now I've taken this and I've completely converted it to u, which means once I take the derivative, all I've got to do is plug in my limits and I'm done. I don't have to go back. So I'm going to rewrite this one more time. U to the negative 1/2 du, okay, because I prefer the negative exponents, so plus 1. So I'm going to get a 1/2. So I have 3 times, remember I have to take account of this, so times 2, which is 1 over 1/2. U to the 1/2 here, and then this is between 1 and 36. So what I have is I have 6 u to the 1/2, 1 to 36. So then I'm just going to plug this in. So 6, the square root of 36 is 6, minus, okay, the square root of 1 is 1, 6. So 36 minus 6, 30. So my answer is 30. Let's go back here to the right thing, and I should be able to put in 30, and this should be my answer. So you can see that for this kind of problem, which is substitution, it was solving an integral using substitution with a definite integral, you're first going to set your u's, get your du, plug in. Then you are also going to convert your limits as well, and then you will integrate normally and apply the definite integral normally. Now obviously, as I said, you could leave these x's here, and when you got here to this answer, right here, 60, you could then put back in this x squared plus 1, and then apply these that we already had. But I think it's easier to do them as two parts. I find it's one less step to remember, and that when I get here and doing this final step, it's simpler for me to see because I've already done them piecemeal. So while this looks messy, it's not much harder than what we've already done. We just need to make sure we're remembering where all our x's and u's are, and that we're all completely in one or the other term. Where you get in trouble is when you only have convert. So you convert this to u's, but you forget to change the limits, or you decide you're going to plug them in at the end and you forget to do them. So there's lots of little steps that are easy to make mistakes in this problem. So really take your time, write out all the steps, and make sure that you are completely u or completely x.